Hi, today we're looking at how the first and second derivatives of our function f of x relate to our graph of f of x. So some of this is a bit of review of what we've already looked at, and some of it will be new. So we already talked about if our derivative is positive, that means we have a positive slope, therefore our function f is increasing. Where if the derivative of f is less than 0, that means we have a negative slope, so f is decreasing. Now, if a second derivative controls our changing of our slope. So if our second derivative of f is greater than 0, our slope is increasing, and therefore our function is concave up. If our second derivative is less than 0, so negative, it means that our slope is decreasing, and therefore concave down. Now, I've created a bit of a table here to go over some common things that happen. We talked about some of these already in the previous set of notes, because essentially we were looking to see what the behavior of our line is in different segments. So if we have something where f prime is positive, that means our slope is already going upwards. And if our second derivative is also positive, that means it's going to become more positive. So our graph in that case would look something like this. So this whole thing, it's positive here, but it's getting more positive as it goes upwards. This one here, once again, starting positive, but if it has negative here, that's going to decrease the positiveness. So typically our graph in that section would look something like this. Now, if we start out with a negative slope and then became positive, that would be something like this. Or if we have a negative slope that's getting more negative, our graph would look something like this over that interval. Now, if we have a positive slope, but our second derivative is 0, that would mean that it's unchanging. So we just have a linear line that is going upwards. If we had a negative slope and our second derivative is 0, then we would have a linear line going downwards. Now, if both of these were 0, we're just going to have a horizontal line. So we're going to utilize some of these to help draw some graphs. So for example, sketch the graph of f of x using the graph of f prime of x shown below. And we're going to suppose f of x is continuous on the interval from negative to 3 to positive 3, and f of 0 is 0. So first thing I would do is split this up into its different segments. So I'm going to split up each location where our graph, which we've always said this is f prime of x, everywhere where it changes slope or where it crosses an x-axis. We'll start at our starting point. Okay, so now that we've done that, I am going to create something like we did with our graphs in the previous section notes as well as on the previous slide. So we'd have f prime of x. We also have f double prime of x and the general shape of f over that interval. So our f prime of x should be fairly simple because we've got a graph of it. Anywhere above the x-axis is going to be positive. So this is above x-axis, so it's positive. This is above x-axis, so it's positive. Here, our line is below the x-axis, so negative, below the x-axis, so negative, above, so it's positive, above, it's positive. Now, f double prime of x would be the slope of our lines here. So we can see the slope here is positive, so that's going to be positive. Where here the slope is negative, so that's negative. Here our slope is negative, so that's negative. Here it's positive, so that's positive. Here it's positive, so that's positive. And here it would be 0. So based off the previous page, we know that if it's starting positive and becomes more positive, we're going to have a graph that looks like this over this section. Here we start positive, it becomes a bit negative, so we know we'll have a graph that looks something like this. And then we've got a graph that's negative becoming more negative, so it'll look like this. A graph that's negative that becomes positive, so it would look something like this. And then positive becoming more positive. And then positive with 0 change, so that would be linear. Now to start out this graph, we're going to mark the starting point they gave us. So we're going to mark f of 0 equals 0 and work from there. So at 0, we're at 0. Now I'm just going to work in both directions. So for example, start going to the left and then I'll work as we go to the right. So we'll look at our intervals. So our first interval here was from 0 to -1. So when we're looking from -1 to 0, the area under our curve would be our displacement. So the area under f prime of x is, if we look at our area here, area of a triangle is 1/2 base times height. So 1/2 times 1 times 2. So that would be an area of 1. Except for because this was negative, it would be an area of -1. So we have a decrease of 1. So we're starting here. We know we have a decrease of 1. So we know we're going to end up here at the end of that interval. But in that interval, we can see we have a curve that is this shaped. And sorry, we had a decrease of 1, which meant that we start here and going to right, we were decreasing by 1 unit. And like I said, it looks like this. So we've gone down 1 unit, like this says. Now, if we look from -2 to 1, we have an area of +1. So we have increased in distance by 1. So if we've increased in distance by 1, that must mean we must have started here to get an increase of 1. Now down here, it looks like we've got this curve in this section. So we should have something that looks like that. Now if we look from -3 to -2, we can see that area under f prime of x is also equal to positive 1. So also an increase of 1. So therefore, we know we start here, but we've got this curve. So we know our graph would look something like this. So we've completed half of our graph. Now we'll do the other half. So now we're going to look at from 0 to 1. 0 to 1, the area under f prime of x is negative 1, so a decrease of 1. And in that segment, we had this curve. So we'd have something that looks like that. Then as we're going from 1 to 2, we have an area of positive 1. So an increase of 1. So we'd end up here. Now, if we look from 1 to 2, we had this curve here. And then from 2 to 3, the area here would be 2 times 1, so an area of 2. So therefore, going from here to here, we have an increase of 2. Now, it showed it was linear here. So our graph should look something like this. Okay, so we will do another example. The graph of f prime is shown below. We want to find the values of f prime of negative 2 and f prime of negative 3. I think I just have one small thing. So if we have the value of f prime of 2 of negative 2, we just have to get that from our graph because this is our graph of f prime. So at negative 2, we're at 0. F prime of negative 3 would be at 2. B, find the values of f double prime of negative 2 and f double prime of negative 3. So that means we want to find the slope at those locations. So therefore, f double prime of negative 2, if we look at our slope at negative 2, we can see that we're on a linear line, so we can just take our slope here. So it looks like we went down 2 units over 1, so that would be a slope of negative 2. If we look at f double prime of negative 3, that here is not a straight line or even a curved line. It's at a sharp edge. So essentially, this would not exist. Now, if we want to find the average rate of change over negative 3 to 1, that'd be our rate of change from negative 3 to 1. So that would be over this interval. So this would be our slope of a secant line. The slope of a secant line. So now, of course, we want the slope of this line here. So to get that, we'll just do f prime of 1 minus f prime of -3 over 1 minus -3. So that gives us 0 minus 2 over 4. So that gives us a rate of change of -1/2. Okay, we want to find all intervals on which our graph of f is increasing. Now we know that it's increasing if our f prime is greater than 0. So therefore, from -5 to 4, or sorry, to -4, from -4 to -2, and from 1 to 3. Now find all values of x at which the graph has a point of inflection. So we know that this is when f double prime changes its sign. So we can see it changes its sign here because it's going from negative to positive. So if I be at x equals -4, as well as at x equals -3, as well as down here at x equals -1.